All right, guys, so how do we feel about that? I'll tell you what, I decided I'll let you keep it. We're going to go over. You ready? I wanted you to really take it serious, though, so that's why you're welcome. So, how's that first one work out? It killed your soul. I didn't even know I had that power, man. What combination of buttons do you press when you're playing that video game? You unleashed math. You have killed their soul. Finish that. Alright, so one thing that kind of comes up in this problem, and definitely in the next problem, is order operations. And that's kind of like the grammar of math. So if I said to you, I live in a big house blue. Do you kind of see what I'm saying? That doesn't work in the English language. That grammar is not good. But in Spanish, you say the adjective in the other place than you would in English, right? So in certain languages, you have to know the grammar of the language for other people to know what the hell you mean. So math is not anything new. Math is a foreign language. It has its own grammar, and it's what we call order operations. So what's the order operations? What's the saying? Or PEMDAS. Please excuse my dumbass son, a Geron son. Whichever one sticks in your head, right? If you have sons, you might have, please excuse my dumbass son. But I hate that it's written like this. Because then people think multiplication before division, and I can't blame you because it was written like this. It could have been written like this. This is exactly the same as what's intended. But how do you say that? PEMDAS. You can't help but sound drunk. So they said, we'll use this one because it's hard to say, but it really should be written like this. I don't like either one of those. Definitely inside parentheses first. Definitely powers, exponents next. Either one of these as they come is next. So if division is before multiplication, you do it first. Right? So it's as it comes. Addition, subtraction, as it comes. You guys with me? That's much better. This one, if people write it like this, I can't fault you for doing multiplication before division always, because that's what it looks like. Right? So here's a really evil problem. I'm telling you going in. What's that? 4 times 4 divided by 4 times 4. I'll tell you this. It's not 1.
0.
It's definitely not 0. Right? I'm not subtracting anything. I can't divide and get 0, right? So what's the order of operation say? It says do multiplication division as it comes. 4 times 4 is 16. 16 divided by 4 is 4. 4 times 4 is... There you go. The mistake, when people do this, now watch, when people do this, this is so unfair. What's the only thing that's being divided? That 4. What's that 4 doing? Times that, right? So let me write that little piece by itself. We'll do this problem eventually. If I just write this little piece by itself, what is 4 divided by 4? How else can I write that? I can write that as 4 over 4, right? So that's 4 divided by 4 times 4. So if you think this is 4 divided by 16, how the hell did your 4 get down there? Did you guys start to see that? So the reason you have to agree with this is because that's the people who created the language. That's the grammar they came up with. You can't come in there and say, I don't like how Spanish is done. I'm going to redo it. I think there's going to be millions of people that go, no, you're not messing with my language. So you can't mess with the grammar math because it is set. You have to just come in and learn it. Just like you would any foreign language, right? Okay, so that's number 1, is trying to clear that up. Because order operations is everywhere. Not just in the section of order operations. It's everywhere. So you have to understand. So here, order operations would tell me to do what first? In the parentheses. I love it. And the only way I can subtract these, common denominator, and there's also something else you should do too, to make this a little easier. Make it in. Currently, what kind of a thing is this? Mixed number, right? It's got a whole part, it's got a fractional part, it's mixed. So I want to turn it into an improper fraction. You guys kind of with me? So how do I make this into an improper? Yeah, 5 times 3 is 15. Plus 1, 16. And what about this guy? 29. I love it. I still got this dude. I'll worry about him later. How are we doing so far? And the reason I do that, if I made this tenths, it would be 2 tenths. What's wrong? I'm trying to take 9 tenths away from 2 tenths. You have to do the whole borrowing thing. I don't know if you ever were taught that. Remember that? I'd rather stay away from that if I could. You know, it's really easy to make mistakes there. So another way to get around that is make improper fractions out of it. And then what do I have to do now? Like you guys told me earlier. Before I can subtract them, they have to have common denominator. So you got to make them both 10. Good. So I get 32 tenths minus 29 tenths divided by that stuff. So what do I get here?
3 tenths.
3 tenths. 3 tenths. How do you divide fractions?
Multiply by the top.
Good. Multiply by the reciprocal, right? It's just coming back. If it's been a while since you took math, somewhere way back in the recesses of your mind, hopefully it's going to come out. So multiply by the reciprocal. How are we doing so far? This should be familiar. Now look, like I say very often, I'm never going to play poker with most of you. I'll show you nothing. All right. And then what can I do here? Do I want to go and make it 60 over? What can I do really nice before I multiply anything? Yeah, 3 goes into 33. 11, 10 goes into 20. So now I get 2 over 11. Take that. So if you got that, you're good. All right. If you didn't get that, figure out why. Yes.
How did we get 3 tenths?
Oh, because 32 tenths minus 29 tenths is 3 tenths. So that actually is why we need LCD. Can you do 32x minus 29y? Why can't you do that? They are not true, so they are not like terms. You with me? So I could not, so like right there, I could do 16 fifths minus 29 tenths. That's like 16 of these minus 29 of those. But if I make them have the same denominator, now I got 32 of these minus 29 of these is 3 of these. Hey, that's LCD is just like terms. Right? All right. Cool. I like it. Some of you guys are like, I know. But I want everybody on the same page. Okay. Any other questions on that problem? Have you guys seen why? Let me focus on this part just for a second. Right here, when I had 3 tenths divided by 33 over 20. Let me see if you guys can deal with me for a second. I want to show you why. Do you know why you multiply by the reciprocal? Or you just know that that's what you do? And the more of that kind of thing that happens, the more you go, well, that's just what you do. That's just what you do. Then somewhere in your brain, you start to lose faith in math, because then it's just a whole bunch of, well, somebody told me to do that, somebody told me to do that. Why? Why the hell do you do that shit? So here's why. Let me see if you guys can go with me. This is nothing you ever have to do. Another way to write 3 tenths divided by 33/20 is 3 tenths. Somebody's going to give up with me at the beginning. That's too bad. Divided by 33/20, right? You guys with me so far? That's ugly, but it's the same damn thing, right? Now, if I can make the bottom 1, then the answer would be what's on the top. You guys kind of with me? I'm just trying to show you the actual work is easy. You just multiply by the reciprocal. That's all you ever have to do. This is trying to show you why that works. So how do I make this 1? It's divided by 20, so I want to multiply by 20. See how the 20s would cancel out? And how do I kill the 33? And if I multiply the bottom by 20 over 3, I have to do what to the top? Multiply by that same thing, right? I've got to do the same thing to the top and bottom, so I multiply the top by 20 over 33. This becomes 1, so the answer is that. That's exactly what we did, isn't it? So that's why you multiply by the reciprocal of the fraction. That's why. So there's always a reason for what we're doing. You never have to go, I was just told to do that. The more of that kind of thing in your head, the less trust in math you have. Right? Okay. Cool. What about part B? This is the straight up, pure, unadulterated, what do you call it? Order operations. The biggest mistake people make on this problem, there's actually two. Two biggest mistakes. People make that 27. I'm sorry, if you did it, it's a mistake. Because do you do multiplication before division always? No, you do that as it comes. So what is, the last thing you would do in this is that multiplication. Because it's at the very end. What's the absolute last thing you're going to do in the whole problem? What's the absolute last thing you're going to do in the whole problem? What's at the very end of PEMDAS? Yeah, you're going to do that subtraction last. 3 minus, I don't freaking know yet. So the whole purpose, that 3 minus is just going to come for the ride. It's at the very end. Erase it tonight. Yeah. It's at the very end of PEMDAS. It's the last thing we're going to do. Now, what am I going to do first? In the parentheses. So I got to do that subtraction first, but it's because it's in parentheses. That gets it gets booted up to be top priority. How are we doing so far? All right, good. The second biggest mistake I see is people do this. -1 cubed is -1, -2 cubed is -8. No. Well, hell no. What are exponents? What operation are exponents based on? Multiplication. I love it. So 2 cubed is 2 times 2 times 2. So they work really well with multiplication. They do not work well at all with subtraction or addition. Because they're not based on those things. You with me? So why is this easy? What would you do here? Actually, let me make that as x so we don't have to do. Wouldn't you just distribute that 3? Isn't that easy? Because coefficients are based on addition. What does 3x really mean? X plus x plus x. So coefficients play well with subtraction and addition. Exponents don't because they're not based on subtraction or addition. All right, maybe. Some of you guys have had me, I say that a lot. I'm sorry, it's just a habit. So I have to do this first. What's -1 minus 2? -3. Good. Notice the next thing I do. Exponents, good. So we did parentheses. Now I'm done inside here. The next thing I do is exponents. What's -3 cubed? Now the next mistake people make, I've made a mistake. What operation is this? Multiplication. Now what is it? Right? That's like water in a wine level shit. Right? You can't make multiplication. Whoa, becomes subtraction. No. It's got to still be multiplication, right? -3 cubed is -27. So this is -5 times that, -5 times what it is. You can't change the operation into something else, right? All right, so what's the next thing I do now? Multiply, good. So that's 3 minus is just coming for the whole ride. And now this whole piece is all multiplication division, so I do it as it comes. So what's 5 times 27? What's -5 times -27? Plus 135, good. And then what do I do next? Division, good. And this is where some of you guys are like, damn, you and your not calculator shit. You should be able to do that, right? 9 goes into 135 how many times? 15. Yeah, so you get a 9 into 135 once. 45, I got it. 5, 15, right? Cool. And then what do you do last, second to last thing? Multiplication, cool. What's that? 45, good? Oh, you were just one step ahead. All right. I was worried about you, but now I'm not. And then 3 plus 45. So if you got 48, you're good. Yes, sir.
Maybe I did it pretty quick, but I ended up going, I guess following the same order of operations, but I ended up dividing by 9 and somehow got the same answer. I don't know.
So you divided by 9 first, right?
Yeah.
And that's okay, because you can rewrite. This is by the book. Then there are little things you could do to kind of tweak it. So one little thing you could do right here is you can rewrite this as that. See the divided by 9, just put it underneath, and then you can reduce that. Sure, hell
It's not
yeah.
gonna work every time, if you follow that.
Well, I'm always careful about saying every time, but if it was exactly like that, yes. Gotta be careful. Because some people will think it's the same problem, it's not really the same, so you gotta be careful. Oh, we're getting there, we're not there yet. Or are we there? Yeah, we're there. Last year it was, we got 20 after, now it's 15 after. Alright, so we'll finish that up tomorrow, bring that back with you, not tomorrow, but Thursday. If you need an antidote, come up and grab it. If they don't have the sticky thing, you gotta write it down, so be ready. To do what? To have a look? Okay. Look at it. Oh yeah,
Break, bro.
grab that. You can't. They don't waste. They're saving money. So just keep track of the code. You need it for yourself. Got it? Okay. Good. Sure.
Friday.
You forget it. Just know the answer. Got it. Thank you. See you. Oh wait. Good. That was hers.
I haven't watched this.
Yours is 759. Yeah, see, that's Isabel's. It's 973.
That's good, man. Hey,
Oh, wow, 759. That would have sucked for one of them. No, but you know what sucks though? Here's the first person, the second person, third person, 7590. Okay, yours is 9734. Good.
I can get Facebook, I have to get Facebook, and I have to get like 5 playing catch up, and then are you saying?
Yeah, so on Thursday, we're going to take a little field trip.
Very, very.
Yeah.
I took a luckily I passed, but you know, I wasn't really